I will tell you when we are live.
Oh, you'll tell me? Okay, cool.
Yeah.
All right, let me just clear out all.
We're live.
We are live?
Yes, sir.
All right. Hello, everyone. Welcome to the stream, I suppose. And shall we get started?
Yes, sir.
All right. So first I'm going to go and open up studio.webaverse.ai. And I am going to go to, do you think we should go with the drop hunter or the neural hacker?
What do you feel like, good sir?
How about the neural hacker? Let's randomize the appearance. There's some very nice visual effects going on here. I like them. All right, well, I don't think we need to fill this out right now. And yeah, let's go get a GLB and download that. Awesome. Now, if all goes well, we can open this up in Blender and see what we are working with. And then based off that, we can start and go. So we can go and implement our Three.js project. Let's just load factory settings so we have a nice default setup. See, that gets us a nice default scene with like all our normal settings, and then file, import, GLB, downloads, anon, get anon 3. Well, hello there. It's the lady. We can go to material preview, which will render it using Eevee. Let's go and I like ambient occlusion, so why not? Yeah, and now I suppose we can see what kind of animations we're working with. They appear to be. Let's see, do we have any animations on this? No, it appears we do not have any animations. As a result, I probably will want to use Mixamo to rig this. I imagine there'll be animations when animations on them in the future, right? Right?
Yeah, well, at least some of the animations will be added, but for the VRM file, I don't think it will be possible. Maybe for the DLP file, but yeah, that's something that might be added in the future.
All right, so let's try doing this. Animations. Upload character. It does not support GLB, sadly. So we're going to have to turn this into an FBX file. We're going to export it. Let's call it. What should we name the character? How about Jill.fbx? Pretty generic name. Hi, Jill. Anyway, now that we have Jill.fbx, all right. This will be critical so we can get a bunch of different animations for Jill later. So is there any way that we can see the chat, see what people are saying?
Yeah, I'm checking that. Yeah, I'm checking that.
All right, cool. Yeah, tell me if there's any questions. Yeah, it says processing character. In the meantime, I suppose I will start doing this. So CD documents. In documents, CD. Let's make dir Webaverse FPS, CD Webaverse FPS, ls, and nothing much. Touch index.html, touch main.js. All right, it's loading. This does look pretty good. Only issue is we are missing any color or texture information. Because you see, there's often a lot of finickiness when exporting from GLB to FBX, And this is especially because Mixamo is using like outdated formats from God knows how many years ago. Let's go and look at limit to selected let's not export any baked animation. So Blender FBX export LBO. And that looks like a gamma correction issue. All right, let's try it again. So yeah, for those of you who don't know, Mixamo is a really great Adobe-based platform, one of my favorite features of theirs, and it comes with a bunch of pre-made animations. You upload any humanoid character, and it applies them. It's like, if you're making a first-person shooter and you need to quickly prototype animations, this is your go-to resource. I used it a lot, and it doesn't have any non-human animations, but for like using humanoids, it has anything from like zombies to Zumba dancing to like dramatic action hero poses. Like, you can find some pretty awesome stuff on it. In the meantime, I'm gonna keep here we are. Next. So as you see, we got her with animations. We just, need to figure out a way to export the colors. Because you see, it's all, it's awfully finicky, really. Let's see how the GLB is storing stuff. It's storing it in a texture atlas. GGX. Oh, yes, that is quite chaotic. So yeah, this is very professional atlas packing. Which one of you guys worked on this? I really like it.
It was a custom atlas packing. We still have to work it to make it like based on size of different sizes. Like ISIS should be slower in this size, but it's a custom made atlas.
Right. Well, here we have a very helpful video tutorial how to export an FBX with a texture.
Loads mark to a chip mark
Okay,
3D.
calm down, Markham 3D.
Delete the default cube and re-add the default. These are the options over here we need to change. We go path mode, we change to copy, and then we need to select this button, embedded textures.
Beautiful. That's what I was missing. Ding, ding, ding. Now we should have the albedo. What else is...
Right here. Turn that one on. Let's just go untitled.
All right. Now we should get the textures. So yeah, I want to emphasize the Mixamo is completely free. I didn't pay for any of these animations, nor is this, like, all you need is an Adobe account, which is free. It's a very invaluable resource. It's great for getting started with these things. So in the meantime, while I'm waiting for that, I am going to boot up my Visual Studio Code. I'm using Copilot. It's $9.99 a month, so it's pretty affordable, but by no means do you have to use it. And yeah, we can go to the top of my documents folder, Webaverse, and open that. Sorry, unable to map your existing skeleton? That's depressing. It seems that perhaps exporting the current mesh didn't... Oh. Alex Toady cannot join the stream. He will be remembered. Let's export as FBX. file, export, FBX. Maybe it's because we had path mode as copy. Let's do auto. And yeah, I guess all will change is we embed textures, nothing else. And let's try exporting the FBX one more time. Upload the character. This is the final attempt, as you were. Do. Yeah, in the meantime, I will start setting up a Three.js demo scene. I'm using Browser Sync. It's very easy to host stuff on. Yeah, let's. There's currently nothing there, but we can change that pretty quickly. Embed abbreviations help you get started real fast. I actually just have a very generic template I use, so let's open up. Sure, SAT Blur. I'll open up one of my previous projects, copy paste some boilerplate. In the meantime, now we're somehow back to the empty character. Damn it. So you know what I'm going to do? I'm going to try to use Mixamo's auto rigger. Oh no, not like that. There, perfect. Now we just have an unrigged mesh that we should be able to export with texture data in a way that doesn't murder Mixamo, and then we can use its auto rigger on the unrigged mesh to get something that's close to the original quality with the texture atlas. And yeah, embed textures is on, path mode is copy. Let's export FBX and pray for the best. Hear that, Jill? We're gonna put you in a game, Jill. We're gonna be there eventually. Anyway, so yeah, for now, In the meantime, I'm gonna get some Three.js boilerplate going. I'm gonna be using release fit 150. You can use pretty much any release. I like using CDNs. You could use a build. Not really the point. So yeah, let's just get started. We're gonna import some pretty basic stuff. I'm definitely gonna be using post processing because I'm gonna go for kind of like a sci-fi vibe. So you're gonna want bloom, maybe ambient occlusion if we have the perf budget for that. There's a lot of stuff we might want. I'll also grab just a bunch of classic utilities that are essential to any Three.js project. Let's get all of that stuff. Yeah, sure, we can get my... no, we won't be using Asset Manager. See how the Mixamo land's doing. Strange. Still not exporting properly. Do you have any idea why this might be happening?
Not sure. Maybe it's not displaying because of the size of the texture. It might be also an issue. I'm not sure because it's a high texture.
How high res are we talking?
Yeah.
Yeah, copy is in path mode, and that little box thing is checked. What's missing? Let's restore operator defaults and maybe let's try batch mode. Oh yeah, there we are. But there aren't any animations. My existing GLBs with all that. There. All right. Well, ideally, we could have figured out how to get Jill exporting with textures, but there's so many competing data formats, it can be difficult to get that done properly. Let's try one more thing. Ah, nope, that did not help anything. All right, I'll try one more thing, and if not, I'll just move on to using a default GLB from XML. Scene, path mode, auto. Let's do copy that. Fill text FBX. All right, path mode off. All right. Perfect. Let's export all of that geometry. Flat modifiers. Sure. Yes. Just export everything. Yes, export all the things. For sure. Nope, we're not doing anything in the armature. Yep. There. There's quite a lot more exported with that. Who knows, maybe it finally contains the textures we were looking for. I doubt it, but To test this, we can import it with Blender. Literally waiting. As we can see. Oh no. Yeah. The point is the textures did come through. I guess it's just not working. I hope you don't mind if I use a preset GLB. Alright, in this case, let's good point. I will try this. Oh, we have a new friend request from the ETH gen. Perhaps they are coming to help me. Anyway. See if it works. In the meantime, let's get back to setting up our scene. So async function main, it's just always good to do that. We are going to basically have our renderer count scene equals maybe 3 dot scene. We'll initiate our perspective camera, and we'll also get that. We're gonna use shadows. For a first-person shooter, I'd probably recommend VSM shadows, mainly because they're smooth. But actually, PCF soft. Controls. We'll start with orbit controls because they're just fun to play around with. We got the stats panel. Let me just I'll be dragging in a quick cube map. All right. Oh, look. I guess we'll be using the white rabbit. Oh, that's cool. Is this related to the Webaverse? All right, next. All right, everyone, meet our new protagonist. His name is Jeremy. Everyone say hello to Jeremy. This was the plan all along. Forget Jill. Jill is goodbye, Jill. It was nice not knowing you. Anyway, Jeremy over here. Let's get an idle animation. Actually, yeah, like that. Look how calm and collected Jeremy looks. I love, personally, I'm a fan of the breathing idle animation. Look, he's Jeremying out. All right, anyway, we'll download the FBX binary, ooga booga, In the meantime, we'll go back to setting up our scene. Copy folder. We're going to do an sRGB encoding. Oh, I got a Discord message. Oh, very cool. I love Jeremy. I mean, no. All right. Anyway, yeah, no. For now, he's Jeremy, but I suppose his official name can be. Oh wait, is this a reference to the Matrix? It's a Matrix reference. Oh, I just got that. All right. Here we have the White Rabbit AccuRig blender, which hopefully includes the animation we were looking for. Oh wait, no, it's going to be this. All right. So before we actually go and get any of that stuff, we are going to go and create our scene, and then we're going to define our animate loop. Oh, see, we're going to want to use post-processing setup, especially because we're going to be using a pixel ratio of 1. So if we go down here, I have a pretty nice setup. What I do is I have a depth texture, I do my own manual render and all that. Oh wait, maybe we have more information about Jeremy. Ah, got it. Many references deep. Interesting fact, actually. Did you know that there's a scene in Alice in Wonderland that mocks Quaternions and how confusing they are? Because the professor was a mathematician, and he mocked them for being really unintuitive and hard to understand. There was an actual, and it's implied in Alice in Wonderland that there's this scene where he's pretty much just ripping into the details of Quaternions. It's really funny. So yeah, anyway, I generally like using an SMAA pass and a very simple effect pass that we can configure later, along with a gamma correction pass. This means we're going to want our renderer.output encoding, 3.linear encoding, because we're gamma correcting it later. And now what we're going to do is renderer. We just are going to drag in a very classic effect shader. Effect shader.js. This is a pretty much generic post-processing thing. Open recent. What would have a good? Let's go and open Minecraft. This is not actually Minecraft. I decided I was going to make a voxel game and then gave up in like 2 seconds because that's what a good programmer does. And yeah, this actually looks quite good. Booga boo boo. And once we have that effect shader, we'll import it. Trust me, it might be starting a little slow, but like in 30 minutes, it will look nothing like we'll actually have something going. Oh, we already imported that. Very nice. All right, renderer.set render target. Perfect. And then we just... And if all went well, that should give us something. Oh, and we're not doing some data tables, we're doing a Webaverse. We have an error. We don't have stats.js. How unfortunate. Oof. Client width is not defined. Oh yeah, that's from another thing. We are actually just going to do a const client width equals. All right, and that is an environment in Three.js in only 27 minutes. Yeah, not my fastest time, but there were technical issues. Anyway, so now you might notice there's this nasty little margin when you want the entire screen, so this is actually a very simple fix. Perfect. Now we actually want something in the scene, so Let's make some terrain for Jeremy to run around. What kind of terrain should we make? Ask chat whether we should go for like a futuristic sci-fi kind of terrain or like a more natural, looking like grassy kind of thing. Tell me which one they're saying more of. Are they saying anything? In the meantime, I will start by creating some ground. Oh. Sci-fi. All right, that makes sense. What did I expect? It's the Webaverse. It's the future. It's the information superhighway. So I think for a sci-fi vibe, what I'm going to want to do is probably like a lot of blocks, not a lot of organic shapes, a lot of hard edges. And for that, I probably am going to want to randomly generate a bunch of platforms. So let's go and do that. I think reflections are also really important because, it's sci-fi. So I might do some screen space reflections if y'all don't mind that. So let's start by creating const ground equal I think the ground should kind of be like metallic black or something. I don't know. So let's do new 3.color. Here's a little hint. Never make your colors white, completely white, because that's not physically accurate. Let's do roughness of 2.5 and metalness of 1.0. And then, of course, scene.add ground. Oh. That's probably not what you were expecting, but does anyone want to? Do any of you guys want to unmute, like comment, give advice, ideas? Because now that we're like in the art phase and all that. Perfect. Anyone? All right then. So yeah, right now it kind of looks like the glossy metallic plane. Not too sci-fi yet, but to start we're going to make it seem kind of infinite. So it stretches yonder forever. And let's increase the camera's far plane a good amount. Perfect. So now it looks like it is, almost infinite. Anyway, now we need to add some random platforms. So for the cool sci-fi look, I think I am going to go with like some kind of metal texture. So yeah, I am going to be a bad boy and rip something off the internet. Metal texture. Note that this is purely for personal use. If you're actually doing a commercial project, make sure you have proper rights to everything that you're taking. Metal go burr. Oh yeah, that looks pretty nice. The only thing I don't like is that the specular highlight's like baked into that. So maybe we go get a metal normal map texture. We also, while we're at it, do you think there should be explicit lighting? I mean, yeah, probably. So let's go get const directional light. Yeah, we can just use Copilot for this one. We're actually going to want. Perfect. Now there is one giant directional light. Also, we probably want to make the plane side. Yeah, the issue is it's way too intense, so we're going to tone it down a fair bit to like 0.1. Now that specular highlight is looking much more reasonable, at least to me. Anyway, all right, ask chat, should we get Jeremy in first, or should we go and make fancy sci-fi boxes, whichever one chat wants to happen first? In the meantime, I'll grab metalness, normal map. Metal, yes. Looks pretty good, pretty sci-fi, pretty gritty. Yeah. So const metalness normal map equal. And now let's actually throw that normal map on the ground. Does chat have a preference between Jeremy or cool sci-fi boxes as our first thing? Okay, that's way too big. It looks pretty good, you have to admit, but like way too big. So yeah. The good news is this gives us a sense of scale. So what we're going to do is we are going to All right, they want the cool sci-fi box. Cool. So yeah, we're gonna make a few cool sci-fi boxes, have them all be of different colors, and then we're gonna augment the whole scene with some nice reflections, screen space reflections. If you want to know the two ingredients to good-looking sci-fi scenes, it's screen space reflections and bloom. Just aggressive amounts of both of those. Now, obviously, it's a little more complicated than that, but So we can set a pretty aggressive repeat, which, oh no, what did that do? Something has gone horribly wrong. Oh yeah, and then we have to do. Yeah. And now, when you're on the ground, it looks pretty sweet. Actually, maybe we'll do repeat 100, 100. And that, my friends, does look a lot more like metal, right? This is looking a little more epic sci-fi vibe than before. So now what we're going to do is make a bunch of cool boxes, because who doesn't love cool boxes? So let's say we're going to use instance meshes, because, we want, say, 10,000 cool sci-fi glowing boxes. We're going to want, to keep the draw call count pretty low. So, and maybe thousands much, but still, okay, so const box count equals 1,000. Const box geometry, yeah, sure. And then box materials for now is just going to be a material with all the same stuff that the ground has. Except the color is going to be a flat 1.0, 1.0, 1.0. And then we are going to So yeah, this is the naive approach, where we just create a bunch of boxes. In retrospect, I think that screen space reflections might be a little too perf heavy for this, considering that we're going to have a bunch of boxes going on, and it might be very chaotic, and given the size of the boxes, it might be pretty jarring, so we might just do ground reflections. In the meantime, however, evidently, the one-by-one boxes are much too small. So what we're going to do is, instead of this, we're going to basically have const box mesh equal new3.instance mesh, using the box geometry, box material, and then box count. And then we're going to create a dummy mesh. Const dummy equals new3.object3d. This isn't doing anything. And then from there, we are going to, rather than doing that, we'll do dummy.position.set. Dummy. And then we're going to do a. And then we're also going to make it so, one, they're distributed across. Oh, I'm kidding. Oh, hello, the Benezer. What's up? I know the Benezer from the Three.js Discord. He's a very cool dude, or maybe a dudette. I don't know. Hello, what's up, the Benezer? Is that how you say your name? All right, that's a responsive type. Anyway, so yeah, and that is at least then what we do there is we'll do dummy.scale.set. Let's do 100 minus times math.random minus 50, and then 25 times math.random minus 12.5. Perfect. And then we are going to do dummy.update matrix, and then this is a very idiomatic pattern, and then box mesh.set color add. Now let's actually do it so we have to apply constant multiplier. Perfect. Now if this worked. Indeed it did. We have a bunch of rather boring looking boxes scattered across the land. Yeah, no, these weren't nearly as epic as I promised, but I promise you, we'll get there. I will deliver you your very precious, totally legitimate, hyper awesome box. I'm sorry. Alright, so what we're going to actually do is create a copy of the metalness normal map. Metalness normal map, no repeat. Small, which is just metalness normal map.clone, but we just change the repeat to the, say, choo-choo. And then we do metalness normal map small over the other ones. So now this means we have boxes with actual metal on them, which is kind of cool. But these still don't look like the kind of sci-fi platforms you might see in like an actual game. They look more like, oh, it's a box. Yay, so interesting. So let's make them a little bigger. We're going to make it so they can be 500 by 250. And we're going to make them so they can be a little thicker too. All right, this is looking slightly more sci-fi, but now we have the issue that add some more variation to these dudes. All right, we have something that's looking a little more sci-fi right now, but I'd still say it's below par sci-fi wise. Like, to me at least, this looks like, yay, we have boxes in the sky, not this is like some weird futuristic facility. So I think step one might be increasing the number of boxes to 10,000. Nope. Too many. Go back. All right, I like 2,500 personally. It creates this like very ethereal, oh, you're jumping from box to box. Now there's this issue of boxes either being way too thin, like this is not what a box looks like. No one can honestly look at this and say, yes, that is box. So what we're going to do to address that, at least quickly, is what I do at least is we're going to clamp it. So we're going to say, yeah, sure. How would I go about doing this? We generate something from math.random, 250 times math.random plus 250 time, and then we just do that instead, which should clamp it nicely. All right, this is looking very more boxy. But now I think there's too many boxes, so let's tone it back to maybe 500. All right, things are looking pretty good, but it still, looks kind of lifeless. So there's two things that I think will greatly enhance this. Thing number one is reflections, and thing number two is bloom. So in order to do the reflections, I am going to go get a mesh reflector material. Because I think the ground should have reflections. The rest of the game can do without them. So we're going to go get mesh reflector material from Oh, the Benezer. Do you want to speak? Or are you having mic issues? That's fine.
No,
Anyway.
I'm back.
Oh, hey, what's up?
Yeah, I just entered this chat from YouTube.
Oh, very cool. So yeah, there's this amazing thing made by our Lord and Savior Obex, or
Okay.
No matter how many times, I'll never be able to pronounce that. But anyway, it's a mesh reflector material. And basically what it is it's a extension to mesh standard material, which lets us implement very nice looking reflections. Mesh reflector material. All right, now that we have that, we can just import it. What does it export? Yeah, it exports the whole damn thing. Yes, just from that. Yeah, we just replace this, which, beautiful. And it ideally works as a plugin jug, but now we need to wait for it to load in post-processing. Oh, and we got an error. Who doesn't love errors? Data texture 3D. Oh. That's a bit brutal. This means we would have to roll back to an earlier Three.js version. Let's see what we were using for the slicer. This is built on version 1.45. I can do that. Replace. Let's just normalize everything to 1.45. Perfect. Now this should work, but it should take a little while to load. So while it's loading, any questions from chat you want to tell me? Or is chat good? Hi, chat. I can't actually see the chat, so it's kind of like, talking into the void. In the meantime, we replace. Oh, they like me. Yay. That's good. Does not require an export named mesh reflector material. I find that a little hard to believe considering we're exporting class. Oh, it's exporting default Didoi. Oh, thanks for the support, guys. I really appreciate it. I'll check out the comments at the end of the stream. So anyway. Oh no. What did I do? I don't see the reflection. I don't see anything at all. Okay, anyway. Let's see what we can find. Yeah. Yeah, it's a little more nuanced than that. I remember now. It takes a little more finesse. So what we're gonna do is let's we kind of need to supply that. So what we do, I remember now, is you can't actually do that. So we'll do ground.material equals. Oh yeah, this is great! Yay! Oh, that's very nice. Anyway, so back to this. Now I'm flattered and thanks guys. Anyway, so what we have over here is the mesh reflector material, which uses the renderer, the camera, the scene, and the ground. And this is just some settings I shamelessly copied from one of my other projects. And then what we'll do is we will kind of adjust this to get a resolution, mix strength. Yeah, so we're going to comment this out to start. Did we get any farther? No, we did not. Fine. Welcome to debugging with N8. Ground up material? What could be going on? Let's start with the simplest one at all, just a simple planar reflection. Strange indeed. Is there anything else we set up over here? Oh yeah, Didoi. Very big Didoi moment. Oh yeah, and because the roughness is 1, it's messing a bunch of stuff up. So, yeah. All right. Just getting all the parameters back. Okay, we're kind of back to where we started at least, but unfortunately I don't see the mesh reflect. Oh, maybe. Oh yeah. Sometimes I remember you have to update it. Ground.material. Yep. Yep, you need to update it in your render loop. Right before that. Perfect. Now we have reflections. Yay. Oh yeah. Behold the reflections you were promised. Yeah. I think they definitely make the game feel more immersive, you know. So yeah. Among other things, I think we should move the platform a little closer to the ground. So let's do that. All right, I think we'll get Jeremy in soon, but I still want to add Bloom first. So I'm going to use one of my favorite techniques for adding Bloom to a game. Edges geometry. Yeah, no, that was not as epic as I expected, but Bloom. Yeah, we need to find edges geometry. That. I use this for my 3D website. Yeah, no. So as you see, what I'm doing here is a lot of just looking at old code where I spent 2 hours trying to figure something out, and then I'm copying what I did there. And there's no shame in that whatsoever, because that's how. Because 90% of what I do is just taking old stuff that I did and iterating on top of it, which is okay. Enough with the inspirational life lessons. Let's get back to the thing. That is the way. Exactly, the Ebenezer. Oh, is that a pun on Ebenezer? Damn, I'm slow on the puns today. Anyway, let me find edges. Perfect. I guarantee you there's some kind of edges geometry or something in Three.js. Edge. Told ya! Told ya! Alright. Okay, maybe that was a little too excited, but so yeah, what we'll do here is we'll create a separate mesh for the edges of the box geometry. So yeah, const box geometry edges equals new 3.edges geometry box geometry, and then we'll create an instance mesh for those edges geometries. And wait, is this lines? No, I hate lines. No, why did you do lines? No, that is not the way. That's not the way, I'm afraid. Yeah, we use line segments geometry. Yeah, exactly. We're going to want to use fat lines. Line geometry. Yes. All right, I have a good idea of how we're going to do this. We are going to import from the Three.js thingy line geometry and line utils. Wait, perfect. So we're going to import. So yeah, ideally we are going to approximate something called a tube light, where you have a stretch and the light illuminates. But you can't really do that performantly, at least not with the Mac laptop I'm on. So we are probably going to go with a much simpler approach, where you just make the lines and then you bloom them. JSM/lines /line material. Beautiful. And then do the same thing for line geometry. Perfect. But not perfect because. See, the issue here is how do you tell it that they're two independent lines without connecting them? Actually, what we could do is, we could use the original instance mesh approach. Or we could do just a separate draw call for each one. Let's start with that, yeah. Sorry for being opaque here, I'm just figuring stuff out. So I think the naive approach here is, yeah, let's go with a naive approach to start. Now let's do the smart approach. Const positions equal Sorry for lack of results, it's just lines are a pain. Because you see, the GPU is very, very, very bad at rendering lines. It's like atrociously bad at it. It makes me sad inside. Hmm. Oh yeah. Anyway, now what we do is no. Perfect. And then no, we will go and const line. Perfect. I guarantee you this is going to produce either nothing, an error, or a highly amusing result. And if it works first try, I will be genuinely flabbergasted. Doo-doo-doo. So yeah, we can just use that. Actually, just perfect. Okay. Well, we didn't actually add the lines to the scene. Duh. Okay, we got a lot of errors. Vertex buffer is not big enough for the draw call. That means we are passing incorrect data somewhere, or in other words, bleeping things up. So we are just going to try simplifying stuff rather than doing all of this. Let's set positions. Three.js examples are everything you'd ever dream. They are the greatest, truly the greatest. Anyway, let's start with just doing that. Maybe it needs custom per line colors too. I doubt they designed it just like that, but that could have happened. Sometimes it helps to get to the implementation. Ah. Wait, maybe we could just do from line on the edge of geometry. Will this be open sourced? Sure, of course. I'm coding it live so you can follow along, but yeah, of course. Yeah, box geometry edges. We'll go. Why did I find that? So we go to edge geometry. Yeah. It should work. Didoy. All right, this should work. Well, at least we got something, but why does it keep yelling me that the vertex buffer is not big enough for the draw call? Maybe it has something to do with the instance mesh. There's other options we have if we wanted outlines, but I think, you know what, for now, let's just try, wait. As I suspected, we might be doing this wrong. The fat lines might be a little different than we expected. Here's why. You need line 2. Yep. Damn it, I am a professional idiot. I was doing, wait, this hurts. Well, to test things, let's get rid of this for now. And instead do, you know what we could do? I actually have a better idea. We could do a backface expand along the normal because of this convex objects. That actually probably would look better, and no, but we probably want it on all sides. So for now, sorry if I'm losing everyone's attention here. It's just these are kind of nasty bugs. It's a very complicated problem outlining stuff, even though it might not look it. So what if we do something along the lines of perfect. This is the fat line. Who doesn't love fat lines? That's the true virtue. Three.js. So yeah, now that we have the thick line, what we're gonna do is, I think, yeah, I have, ideas are forming. I tell you. So if we go to line 2, geometry, yes, this is beginning. The ideas are taking form. I tell you, the ideas are taking form. Okay. So now what we're gonna do is positions. We'll manually encode that push. At the moment, this is just toy stuff. Plus 20, plus 100. And then we also are going to do colors. Actually, for now, let's just do positions. Good idea. Very nice. This is why we love the community. The community is the fastest one of them all. Let me just try finishing up this idea, and if it doesn't work, we can go with mesh line. Sound good? Yes, it worked. It worked horribly, but it worked. You might say, this does not look like it worked. I tell you, it worked. See? Work. This is clearly something that worked. No, but now that we have lines working, we can do a lot of stuff with this. So what we are going to do is we are going to use independent line messages for each one. It's not good on the GPU, but it's good for a quick stream solution, especially considering there's only 500 boxes and that these line messages aren't going to be casting shadows. It's going to be maybe 500 draw calls tops. So yeah, nothing to worry about there. So yeah, what we're going to do is... yeah, and also these appear to be constant. Oh no, they're not constant in world space. We'll do Trust me, this is going to start looking exponentially cooler in just a few seconds. Yeah, how do you do the world space attenuation? World units. True. Oh no, now they're gone. That's because we were probably doing it. Perfect. Oh, but now it's running at an alarmingly low frame rate. It could be because of overdraw. Yeah, that's probably because of overdraw. I know. Wait, why are we computing the line distances? Don't compute the line distance. Yeah, I'm pretty sure the reason this is taking the frame rate is because... ideas are forming. All right. We're going to keep this because otherwise we get overloaded with way too many draw calls considering we're making 500 boxes. And what we do is we augment this by world units true, and then we keep it set to around 10. This should make the lines constant in world space, which is very cool. Very cool indeed. We want to get rid of compute line distances. I'm not sure what those do. Don't worry, we're getting close, I swear. Do. All right, now we can just use basically boxes for each one. Copilot got us covered here. Perfect. Now we got the outline of each box, which is pretty cool. Now we're just the way we're gonna make sure that. The only issue is now they're still all connected. Yeah, perhaps the time has come to explore another solution. I am in agreement with the chat. This might not be the direction that leads us to victory. Sadly. It's important to not get too caught up in a single solution. All right, let's try a much more simpler solution. It's not nearly as cool, but it should work. Sorry for taking the time off the stream, everyone. I perhaps got a little too caught up in my dreams of the lines, and not everything works out. It's an old technique, what I'm doing, where basically what you do is you create kind of an imposter mesh around the thing, and then it kind of renders like that, and it ends up creating cool-looking outlines. It's a very old technique, but it looks pretty good, in my opinion. Or we could just do wireframe rendering. Perhaps that is the best solution for now. Now we just make sure the color are the same. Yeah, there'll be issues with defining. So what if we just did wireframe rendering? This is how I did it back in the day. We could just try this. All right, we got some lines. They're all hanging out down here. I'm just doing here is just mapping the ends. Ta-da! After so much time, there are finally lines. Hard-won lines. Yeah, so we got lines. Let's beef up the radius a bit. Yay! Thank you, Ebenezer, or Ebenezer, whatever this pun is making. Yeah, we probably want to shrink them a bit. All right, let's just play around with the line material a bit more. So yeah, now that we have lines, we can use an Unreal Bloom pass to capture them. Step one is going to be using the color. It's going to be a little more than just white. We're going to do new3.color, color.r times 10.0, color.g times 10.0. This will make them emissive. Okay, I think that looks pretty good. Or at least it looks passable. There's some aliasing in the distance, but you know. And then the way we're going to make sure is what we're going to do is color.r round, color.r. Perfect. Now we got all sorts of cool rainbow colored lines and the like. Maybe it's because I'm in world units. Yeah, let's actually keep things in pixel units. Mainly because it reduces aliasing and the world unit implementation is kind of biffed. Yeah, because when you keep things in pixel units, the aliasing is a lot less bad because it doesn't shrink into nothingness in the distance, which is, a big plus. All right, now that we have that, we're going to change our render type target to a half float. All right, get ready for everything to get a lot cooler very fast. WebGL render target type 3.float type. No, actually, half float type. Half float is much faster than float. Now we're going to get Unreal Bloom Pass. Beautiful. Now that we have Unreal Bloom Pass, we can achieve the stars or also let's for now we're going to disable shadows because we're not really using them. The reflections are what ground our scene. It's very important with any scene that has a large planar thing, like a large ground plane, you have some method of grounding it. So you know what's on the ground and what's off the ground. And generally, reflections and shadows are the two most concrete ways to do this. Ambient occlusion also helps, though it's limited if you do it in screen space. So anyway, now let's go to our effect composer. That's like the most default of Unreal Bloom passes. Okay, now once it loads, we should have Unreal Bloom in our scene. In the meantime, in order to make things more cyberpunky, I probably will tone down the environment map a bit, because the only thing that doesn't look dark and futury about this is the fact that it's not very dark. Okay, that's way too much bloom. We are going to counteract this by... Yeah. God, this is an atrocious amount of bloom. Yeah. Help, my eyes, how they burn. Let's try making it thicker a bit. Okay, for now, we're just going to stop setting the end map. That background is nothing. Hmm. Yeah, let's go get better Unreal Bloom settings. You have to be careful with how you do it. Because it computes, I think, the average luminance. Yeah. All right. After the bloom, I think we should go and get like a cool cyberpunk night background, and then we go get Jeremy. How does that sound? Unreal Bloom Pass. So yeah, I think what we're gonna go through here is strength. That's a little much for us, so we're gonna probably go with 1 point strength. Radius, we're gonna make it very large, and we're gonna lower the threshold a bit. Okay, that's something else that's utterly horrible. Yeah.
Reduce the radius.
What?
Make the radius a bit smaller, yeah.
Yeah, I'm fiddling with the radius right now. Yeah. Ah, yes, this is looking better in my opinion. Yes, that's how you do that. Yeah. Threshold. Yeah, this is much too strong. I think 1.0 is a good strength. Maybe turn down the radius a bit. Personally, I like this look. Very cyberpunky, very futuristic. We can change the ground to be a mirror reflector to make it better reflect the illumination and all. Oh no, something horrible happens when you go under. Alright, yeah, this looks pretty sci-fi to me. Next up, I'm going to add some fog, because right now the whole scene looks very chaotic. It's not very volumetric, you know? So for now, I think we're just going to do very simple 3.js and never use linear fog. Linear fog looks bad. It is not good. Linear fog, bad. Just remember that. We're gonna use exponential fog. Fog X2, beautiful. And the color of our fog is, if you can guess it, it's going to be black. Yay! Yeah. We want a point where let's say we want the fog to kick in to 1 around. So the formula for the fog, I believe, is this. It's going to be an e to the negative x. Deal that. So, yeah, we have e to the negative 0.02x, or there's negative cx. Negative c 2000 equals 0. Where's the solution? It's going to be some very small constant. Oh, you'll hit, as I predicted. Yeah. Well, let's just tinker around, actually, see what looks best. Kapoo! Doesn't that look so much better with just like a small amount of volumetrics? The only issue is that the line material isn't being affected by the fog. That is actually quite an issue. Yeah, we can use them, the AI Skybox Labs, to find a good cool thing. All right, yeah, so let's maybe do 0.005, which would provide a bit of a harsher fall off. And see, the lights aren't doing the fall off because, I don't know, they're bad for some reason. I don't get why they'd be like this, but so what we're going to do is manually do that for them. It's probably because the line material does not implement fog in general, so instead we're just going to fade them by their distance to the camera following the fading curve of the fog. Const lights equal. Yeah. All right, what are the community recommendations? Well, see, I'm concerned that you have to go a little farther than fog true. Huh, maybe it just wasn't set as a default. Oh yeah, that worked. Thank you so much. I really appreciate it. You're a cool dude. Thumbs up. Oh, I got a notification in the Webaverse. Where's my mention? Oh wait, nope, that's a very different server. Anyway. Oh god, there's Discord mess. Oh, okay, yeah, Piglo's pretty cool. Yeah, I've seen Blockade Labs before. It's pretty awesome. So yeah, right now the Unreal Bloom Pass looks pretty good, but I have to say, yeah, maybe we turn up the intensity a bit. Let's maybe beef up the radius and the strength. Make the bloom more prominent. No, because that leads to weird aliasing. Maybe that's because of the half float type. Float type. Default temperature, yes, use that. Oh no, that did something horribly wrong. Texture clone, so just takes the same attributes. Alright, there. I think that looks pretty good, in my opinion. The only complaint I would have is that there's a little bit of aliasing. So what if we SMAA twice? No, that does not improve anything. Yeah, what if we SMAA right after that? Nope, that's still no improvement. Perhaps the radius was too high. Yeah, let's try that. Yeah, I think this is ultimately a good compromise between aliasing and blue. Yeah. You know what? Let's take the leap and do a full. Client width. That should help. Perfect. That got rid of most of the aliasing. But now the perfect shit. So yeah, let's wind back a bit. What settings did I use in the? What if we tried reusing these settings? It was very strong, but with minimal radius to avoid aliasing. And yeah, I actually like that. It's quite a nice, strong bloom, but there's less aliasing issues. The only problem is how pronounced those bitmaps are. Actually, quite brutal. I think so it uses both of those. Yeah, I have to say, this is just really disappointing quality from Unreal Bloom Pass. Maybe I do my own bloom. Except less aliased using a Gaussian card. Yeah, we could do that. I know this sounds crazy, but I could probably get it done in 10 minutes. Implement Bloom. Come on, Copilot, do the thing. I'll probably do do we want the bloom to have a constant size and screen space? No, we probably want a large Gaussian kernel for this. GPT-4 wrote me some nice stuff for this. Write the code for a Gaussian kernel with a uniform number of steps along each axis. How long do you guys want to go? I can stay till like 4:30 or 5. Okay, so. Now you might wonder, doesn't it kind of defeat the point if you just go and ask GPT-4? And I say no, it's a productivity life hack. That's what we're doing. Actually, I'm not sure if this will do any better considering the... yeah, probably. Let's just stick with what we have and then deal with it later. Yeah, we have too much stuff to do. Sorry. Sometimes when I'm working on my own, I get completely sidetracked by my own thing, and then by the time I come back to Earth, it's been a long time. Unless we go and use my custom bloom path that I implemented. Okay, yeah, no, we're just going to use default bloom for now, even though it looks kind of bad. God, the aliasing, it pains me. Anyway, I wonder if there's a way to soften it. Yeah, maybe if we just reduce the radius. Unreal bloom path. Okay. Yep. What if I just increase the number of MIPS? This should help. Yeah. Huh. Well, seems to have very good results. I mean, sure. In the meantime, yeah, I think we might by doubling this get stuff. Yeah, that does seem, for me at least, to alleviate a good amount of the aliasing. But yeah, we're sticking with that, I suppose. I think the larger radius suffers from less. I think less strength to avoid aliasing artifacts, larger radius, and maybe a little more, but not too much. Yeah, personally, I think this is a good compromise between speed and quality. Okay, now we have, let's just call it psychedelic platform world. Let's add some dithering in. So what we're gonna do is, yeah, because see how there's all these ugly banding artifacts that can be fixed using dithering. So yeah, we can just do. We literally don't need anything other than Copilot can carry this. Alright, the dithering should help with that ugly banding. Common with 3 M's. The M and M and M common. Look, and all the ugly banding artifacts, or at least most of them, are subtle, less pronounced, or just all around better. So yeah, I think this is a pretty good platform for dark sci-fi world. The only issue is there's kind of the environment lighting does not match at all because we're still using a sky. So yeah, we're going to go with Sky Blockade Labs, which I absolutely love, adore. Yeah, confirm. All right, we are going to go with I'm sure they have a sci-fi. Yeah, cyberpunk glowing platforms with all sorts of beautiful RGB lights. Let's see what we get. I find it so cool that this is just like available for free. I suppose it's really good marketing, but like yeah, this is like this mid-journey quality stuff for such a cheap thing. Anyway, in the meantime, shall we get Jeremy in the game so we can actually start, making the game? The game is going to be a toy game where you just like jump on platforms and stuff. But yeah, let's get Jeremy. Jeremy. Oh, the Benezer is typing. What does the Benezer have to say? Okay, in the meantime, I'm going to get our FBX loader to get Jeremy to come in the game with us. The Benezer, what do you want to say? You're typing something. Good idea, good idea. But this definitely kind of fits our lighting. Yeah, maybe Cyberpunk City. Good idea. You probably have more experience prompting this than I do. Okay, what's the error? Where is FBX loader stashed? Should be right there. I knew I'd messed something up. Never trust your typing abilities. Alright, now we can get Jeremy in the game. Alright, everyone, give it up for Jeremiah! Okay, anyway, yeah, I guess once we have done all the lines, what we'll do is, const Jeremy. No, sadly, it's just named, yeah, we're gonna name it Jeremy. You might wonder, why did you choose Jeremy? And I'll say, I have really no idea. It sounded like a funny name. Scene.add Jeremy. Come on, work on the first attempt. I know you. Nope. That's not a thing. Huh? Guys, look! It's Jeremy! Jeremy confirmed! Jeremy just lying on the floor?
He's not dead, man.
You know, Jeremy has left the world. Jeremy has had enough of the grind. This is Jeremy when the NFT rug pull happens. Don't rug pull, kids. This is what happens to Jeremy. Jeremy. Alright, let's actually revive Jeremy. Jeremy dot rotation dot x equals math dot pi over 2. Oh no. Jeremy, where did you go? Jeremy, where did you go? Oh wait. Math dot pi over 2 is 90 degrees. Oh no. Jeremy! Jeremy, why are you down there? Alright, guys. Introducing the modern man, Jeremy. Ladies, are you tired of all the Jeremy? Okay, anyway. Maybe I'm having too much fun with Jeremy. Traverse. Alright, let's slap the environment on Jeremy so Jeremy isn't so perfect. Now we can oh wait, Jeremy's still Jeremy. Jeremy. Okay, how's that for an environment? The only issue is that all the neon lights should be above, not below. Let's try that. Jeremy, why are you using mesh fong material, Jeremy? Jeremy, this isn't how we do it. No, Jeremy. Okay, if anyone would like me to stop saying Jeremy every 7 seconds, you are welcome to request that. Okay, apparently we're not allowed to modify Jeremy. It does not like. Okay. This is not any better. So it doesn't like when we overwrite the material for something. Does it work if we just overwrite nothing? Okay, that worked. It's the derpiest Jeremy of all time, but it worked. So when does the error come in? Exactly. Ah! Aha! It's a material array. That is why everything was going wrong. I am not used to using material arrays, mainly because I loathe material arrays. Jeremy? Jeremy? My dear Jeremy, where have you gone? Oh wait, yeah, that. Return. Alright, then. Guys, look! It's Jeremy integrated into the lighting of the environment! Yeah. Whoever made it so material arrays were a thing, I mean, they're actually quite useful when you want to render a buffer geometry with multiple materials. Yes, I am using GitHub Copilot. It's a wonderful software. I explained at the beginning, but yes, $9.99 a month. No, not $99.99. Like, it's $10 a month. Very easy, very simple, and it codes incredibly well. It makes me twice as productive. All right, next up, we're going to want to shrink Jeremy a wee bit. All right. We're still trying to get a good cyberpunk world. Yeah, floating neon structures and flat ground. Yeah. Another thing we could do is just generate an environment map from the scene itself, but I kind of like having like the ethereal cyberpunk lights in the background. Anyway, in the meantime, shall we get Jeremy all animated? Animate the Jeremy. Jeremy, you don't seem to be animating. Why aren't you animating? Three.js's animation system. It makes a lot of sense until it doesn't. Well, let's see what animations Jeremy comes with. Oh yeah, Jeremy doesn't actually come with any animations, but if we load breathing idle 17.fbx. Guys, behold, Jeremy, he's just taking a break from life. Jeremy. Jeremy. We also want to avoid thrust compelling. Okay. Now Jeremy is eternal, and yeah, we should probably get rid of the rotation because Jeremy's animated correctly now. Alright. Behold! It's beautiful! Everything you could ever ask for. This is perhaps the weirdest game I have ever made. Anyway, we're now going to want a Jeremy running animation for when he, So we're just going to do the derpiest running of all time. Naruto run. Oh, we don't have Naruto running. There's a... Dun 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 dun. Okay, yes, we are doing this. If anyone objects, there's no escape. Jeremy's gonna become an Olympic athlete. Look at that. Look at that arm motion. Sorry, maybe I'm finding these too funny. Or oh no. Yes. Yes. Jeremy, okay, anyway, see if this is better. Okay, yeah. Let's just try flat ground till horizon, loading cyberpunk neon in the sky. All right, I'm down to go till 5 if you guys are. Does that sound good? Plus, I want to make sure Jeremy gets his due justice. Guys? Huh, all right. Anyway. Oh, someone's typing. I don't know. I just love mesh reflector material, mesh reflection or reflector material. Thank you so much, Obex, for that. Anyway, now that we have running. Oh wait. Oh my god, this is the best preview ever. Anyway, let's see what's going on in Three.js Journey, if you don't mind. Oh. All right. Anyway, let's get our const Jeremy running. And now, if we change the animation, I've been trying to find a Naruto run, but I couldn't find it. Do you guys know the name of it on Mixamo? Let's try and look. Wait, what if we negated the character arm space? Yeah, I don't think there was a Naruto run, sadly. No Naruto Jeremy. Let's find the stupidest looking one then. Okay, what if Jeremy's run cycle was just this? Okay, chat, vote. Do we want the normal run or the, this? That send messages. What is chat saying? I can't actually. Oh. Is chat on agreement that this is the true form of Jeremy? Or do they want normal Jeremy? Alright, well, very well, we'll go with perhaps the most demented Jeremy of all time. Why? Why do you guys do this? This is the worst. This is like this Jeremy's gonna be very mad at all of you. Yep, this is our run cycle. But it actually doesn't look very seamless. Yeah, they're snapping. Alright, they have spoken. Alright, this shall be our run cycle. Why are you guys all such trolls? Alright, I think this is what we might be looking for in terms of our lighting. Let's download that. Beautiful. How big is it? Big enough to provide very nice lighting. So yeah, guys, prepare to see in all its glory. Ta-da! The world's greatest run cycle. It's right there in all its beauty. We love you, Jeremy. Make us proud. Exactly. I prefer to interpret this as Jeremy when he realizes that the centralized banking is a scam. Or in some other NFT joke. Literally me when I'm running from the bank. Or running to the bank. I feel like there's like Silicon Valley memes you could make out of that. Oh my god. No, Jeremy. Alright, apparently Jeremy's a community project. It used to be called White Rabbit, but now it's Jeremy, and or it could be both, Jeremy the White Rabbit. Anyway, yeah, very cool. I love like communal icons and stuff. There's matrix symbolism. Anyway, though, let's get a better looking env map. So let's just rename this to env map, and then yeah. Oh yeah, obligatory Twitter check, because, you know, why not? Oh, I got notifications. Oh, awesome. He is making cool sci-fi box. This is the accurate description of this project. Okay, so it should work. But now there's no environment. It's so cursed. Just Jeremy. Anyway, no, what we do is we do. You need to specify that it's the accurate rectangular reflection mapping. Webaverse characters as well as GLBs from different sources. Guys, behold! Look at how cyberpunk things feel now. We're so cyberpunk, isn't that right, Jeremy? Jeremy. Try Webaverse characters? Wait, we're gonna have to say goodbye to Jeremy? Yeah, sure. We can add Webaverse GLBs as NPCs or like enemies and stuff. The only issue is that they don't have animations. Oh, later, yeah. Yeah, that sounds great. And then, yeah, Jerome came to save us because the Webaverse wasn't doing exportation properly. But as long as it shoots an animation, the idle animation, we can make use of, definitely. The only thing I don't like is that now Jeremy's reflection has kind of gone away. Like, it's still there, but it's faint. Works. So, now what we're going to do is make it so you can actually see the cyberpunk background. But no, I kind of feel like it works better this way. No, I think this looks good. Guys, do you think this looks good? I think it does. Doesn't necessarily have to be physically accurate to look good. At least that's how I feel. Alright, let's make an actual little character controller for Jeremy. So this is the coolest part, because we're going to take Jeremy from 0 to hero. So yeah, for this we're going to use 3-mesh BVH, create a bounding volume hierarchy with all the triangles that we need Jeremy to collide against. And then we'll use a capsule entity that I coded to create a little physics engine. Good idea. But I'm not sure how that would integrate with the fog. It's enabled, mind you. It's just not. It'll get all fogged out. Oh wait, never mind. I actually like this. Do you guys prefer this? Or did you prefer the fog version? Alright, anyone else have opinions? Alright then. If you guys. Okay, cool. We'll keep this. As people evidently like it. And the cool thing is the platforms still kind of have this like fade out fog effect. The only thing I might want to do is like reduce the intensity of the environment a little. No, we can do that in post-processing land. I'm just going to reduce the intensity of the environment so it kind of like fits with the background a bit. Because right now it's very jarring because it's like black and then suddenly, OMG, random cyberpunk lights! And all that. You know. I'm sure you guys understand. So I think the way I'll do this is, there we are, and then we go to Effect Shader. There we are. That lets us add a constant multiplier to the environment. Oh no. Oh no. We can fix this. There we are. What do you guys think of that? The background looks a little more muted. Or did you prefer it like big, bright? Maybe I'll modulate it by like half. Yeah, no, I think full strength actually looked best. Yeah. Do you guys think I should keep the fog now? Given all of this? Yes, we should definitely keep the fog. Without the fog, it turns into an oversaturated mess. Of course, once it's over, mind you. I'll send you guys the zip of the thing once it's over. So you guys can run it yourselves, actually. All right, got it. The message from the people is it's time to stop fiddling around with the graphics and make the bunny go boom. So I hear the message from the people, I acknowledge the message from the people, and I accept that the game will look the way it looks and everything will be totally okay. Anyway, yeah. All right, I'll turn the bunny into a character controller. First, we just need 3 mesh BVH. All right, I'm gonna give myself a challenge to do this by 4:30. So, are you ready for extreme sprint mode? 3 BVH. Ding ding ding. Even mesh BVH. I use a lot. So yeah, the way we're gonna do that is we also need buffer jam bills. So yeah, we're basically going to be doing physics from scratch, but luckily I've written a lot of boilerplate for stuff like that. So we're going to do All right, so now we have the wireframe that shows the now that we have the wireframe, let's color it. Sorry, I got distracted. All right, now that we've implemented that, we can see in full color where the triangles that we will be adding to our collision message are. Very nice. And then we just build a 3-mesh BVH around this. And then we'll just run a collision on the BVH, very easy. We just specify the bounds tree. And then what we'll do is we can do, here's the cool thing, we can do a help mesh BVH visualizer, so we can just make sure it's working. For those of you who don't know what 3-mesh BVH is, it creates a bounding volume hierarchy, which is a way to accelerate scene collisions and do them very effectively, implement physics. It has a bunch of utilities. It's made by G.K. Johnson, former NASA engineer, really all around awesome dude. Yeah, if we add the visualizer to it. Oh, we got an error. Oh yeah, because merge geo. Geo, where are we using merge to geo? Merge geometry. There we are. Alright, now if all went well, we should see. Yeah, and then we just set it to true. Now we no longer need this. And see all these green boxes? This represents the different clusters of triangles that 3-mesh BVH made for us. And then when we query the stuff for collisions, it'll be a lot more efficient because of this. This will let us have thousands of platforms or colliders with millions of triangles and still maintain really beautiful, smooth frame rates. Isn't that awesome? This is the part where someone turns on their mic and says, awesome.
Awesome.
Thank you. Thank you. Truly unprompted reaction right there.
Awesome.
Yes, behold the awesome army. Anyway, so yeah, from here we can import I have a capsule geometry. We can go get the capsule entity. We're going to be using a capsule to represent the bunny because that is what all the pros do, apparently. And it works pretty well. We can just yoink this. This is all we need for good physics, believe it or not. Capsule entity. This is literally just hand copied from Mesh BVH, which is just goes to show what an amazing library it is. Seriously, I love it so much. Maybe a little too much. I've used it for literally everything, and this video isn't sponsored by Mesh BVH. It's just like the greatest library of all time. Well, except for Three.js, of course. But anyway, as we get back to it, so now what we're going to do is, as you can see, we can go over here and design a collider for our capsule. And when was capsule geometry added? Do we have 3.capsule geometry? No, we can visualize it other ways. So next up, what we're going to do is find a capsule. We're just going to make keys. For now, we're not going to add jumping or anything. We're just going to add like, hey, you can move around and stuff. So. This is obviously much too small, but we'll scale it up later. Anyway, now that we have player capsule in the game, what we're going to do is implement a very basic physics loop. Which literally comes out to this. All right. Error, no error. Yep, error. Forgot to import capsule. The first thing we'll notice is that Jeremy has left. It's unclear where he's gone. He'll be forever remembered. Goodbye, Jeremy. You were a good rabbit. Yeah, so the capsule entity may not have been... It might have fallen through the floor. So player capsule... Beautiful. Behold, Jeremy. Now the capsule's a wee bit too big. We're actually going to visualize this using what else but a Three.js capsule. We don't have capsule, I don't think. No, we have it. We have it. So this will let us see. There, that should create a proxy that stands out fairly well. Now, where is the proxy? That's the real question. Update what in the render frame?
Oh, update the position.
It is? I think I might be using capsule geometry wrong. Yep, it used capsule geometry wrong. Damn Copilot. Behold. Look how tiny! So we need to make a capsule befitting the size of Jeremy. Hold. For now, I went with hypermetallic capsule because why not? Oh, wait, why did it get so much smaller? Wait. No. Hmm. This is weird. It's not updating according to the height. Maybe it's just because it's not logging the height. Behold, the capsule. It's beautiful. But yeah, let's divide that by 2. Getting closer. It's an iterative process. Perfect. This is actually the capsule. So as you see, it's much too big as of now to represent a little boy. So we're going to make it transparent so we can kind of see through the proxy. You can see our boy behind it. So yeah, as you see, it needs much shrinking to properly ink. So yeah, let's get it on the scale of Jeremy. Perfect. Jeremy capsule. But why is it floating? That's the real question. I think that's a pretty good fit. Don't you guys agree? Now we just take Jeremy and then translate him down a bit. Where did he go? Oh, wait. All right, that should work. Perfect. The only issue is it's still a little too tall. Uh, almost perfect. See, it's iteration like this that you gradually get to the final result, especially with like a framework where you don't have a visual editor. Perfect. Now Jeremy actually stands on stuff. We're so proud of him. So now the plan is this. We are going to make it so you can actually move the Jeremy using a very simple script. All right, guys, who's ready to move the Jeremy? How is chat doing? I hope I didn't bore you with all the, oh no. Thing happened. I have the speed factor, I suppose. Guys, behold, after all this time, Jeremy can move. He moves.
Hey.
There's still a lot of work to do, but now he can collide with stuff and move, so, progress. I think step one is making it so the camera actually tracks the Jeremy. Yes, Jeremy is ice skating. At the moment, Jeremy is not doing much more than ice skating, but trust me, we will get him there. Next up, we'll do maybe control max distance equal 40. This should lock us closer to Jeremy. Yay, the chat is celebrating! Yay! All right, yeah, I think we're getting towards some more natural for third-person controls. Next step, now we have to have Jeremy point in the direction he's facing. This isn't too hard. Jeremy.rotation.y equals math.atan2. Jeremy.player capsule horizontal velocity x horizontal, yeah. atan2 is an amazing function. It solves all of your issues. Behold, now Jeremy actually appears to be moving in directions. Pretty cool. Next up, we're probably going to want to get rid of the proxy volume because we're not using that anymore. So proxy.visible equal false. And now what we're going to do is make it so Jeremy blends between his idle and running animations, so it doesn't just look like he's ice skating dramatically. He's Jeremy, the number one, scare me, Jeremy. All right, anyway, enough fanboying over Jeremy. We have probably serious stuff to do. Okay, this is not serious stuff, but it's certainly fun to do. Anyway, yeah, so let's make it some, idle.play. First, I think first we got to get Jeremy moving. I think the FPS part might come later. There's going to be a second part to the stream. For now, just getting so no, in 2 weeks we're planning to do the stream again. Yeah. Second part will be guns, enemies, all that stuff. First part was just, setting up a thing that you can move around and stuff. All right, guys, now we should have some animation blending for Jeremiah. What is this? Yes, let's go. Onward, fellow friends. Really the greatest of all time. His name was Jeremy. He wasn't scared of anything. Okay, anyway, let's add jumping. Oh, you actually did that as a pretty simple. Should we keep that? It was an accident, but it's kind of funny. Guys, do we keep that? Do we keep the crazy jump animation, chat? Yes, it's the weirdest thing. Just go right to the moon. Boing! I also probably need to make Jeremy go up faster. But also have a normal jump. Good idea. Good idea. Well, what if the premise of the game was that there was no normal jump? It was just Jeremy going absolutely insane. Like it's some whack-ass platform. Okay, yeah, good. Okay, we probably want to speed up the running rate a little bit, so there we are. Okay, I'm liking this gameplay. It's very fast, very aggressively paced. Clear that no one's stopping Jeremy today. One thing I think we should add is a shadow for Jeremy, because that's important to ground him in the scene. Because right now Jeremy's very, Jeremy. So, yeah. We're going to return. True, we're going to bring back a shadow map. All right. Yeah, sure. I'll do that before the end of the stream. First, I want to add the shadow. Oh no, not Steam. Boink. Boink. Okay, yeah, so good. There's. All right, guys. We should have moving shadows on Jeremy now. We just need to make it so Jeremy casts shadows. Guys, look at those hyper realistic Jeremy shadows. The only issue is that they're not easily visible. simply because the surfaces are too metal. If we turned up the all right, yeah, I like this. It's slight grounding. I still feel like it should be a little more pronounced. I'm not sure how to do that. So yeah, like the indirect specular is really murdering the quality of the shadows because of the lack of specular occlusion. Now we could use screen space reflections for this, but what if we just directional? Yeah, we could just amp up the power of the directional light a wee bit. Not as much as we did for comic effect, but like, yeah. There, I think that looks good. There's just issues with light bias. All right, now Jeremy should be complete. Weird, no, I still get that artifact. He has to be even more aggressive. I'm just trying a few visibility things to make sure that Jeremy has a shadow. Yeah. No, I'm happy with the shadows as they are for now. I don't think we should obsess too much over them. Wait, I got it. I got it. The box mesh doesn't cast a shadow, so Jeremy is always exposed to the sun. And then we amp up the strength of the directional light a bit. So now Jeremy always looks like he is casting a shadow. Ding, ding, ding. Hacks. Perfect. Now you can always clearly see whether you're on the ground or not. The power of Jeremy. Okay, there's clearly still stuff to work on, but things look, I'd say, pretty good. Should we add a normal jump and then call it a day, do you think? Sounds great. So super jump is gonna be Q. And actually, we'll keep super jump as space and then add a normal jump. Yeah, super jump is a no. We'll make it so super jump is shift space. Beep boop. All right, let's go. I'd also get rid of the camera helper. No. All right, I'm pretty happy with this. I think we have a good start to a platformer. I'll record a quick video as you asked, and then I'll zip the files, send them over to you guys, and then in 2 weeks we can do part 2. Sound good? We'll have to download the movie as it's a bit too big to play in Discord. So yeah, that's the zip, and then the movie that you guys can do with it's 186 megabytes of footage, and I'll also send you a Discord compatible one. Here's a Discord compatible one. Are we still streaming? I don't actually know. Oh, hi chat. Yeah, so I think we're gonna be wrapping things up. Thanks everyone for coming out. And yeah, it was pretty awesome. And hope you guys enjoy the content.
Thanks, Nate. Learned a lot from this stream.
Yeah, thanks. Yeah, it was fun coding it, and I hope you guys enjoyed learning from Jeremy. The Adventures of Jeremy Part 2 commences in 2 weeks, where we add people for Jeremy to violently murder.
Thank you, sir. Loved it.
Thank you very much.
Hello everyone and welcome back.
All right.
In this video, I have a cool application that you can check out.
I suppose I'll be
from
signing
Google
off
Play
now if
Store,
you all don't mind.
And this one is available under the name of Omnitrix.
Unless there's anything else you want me to
Omnitrix
do.
is a watch from Ben 10, and the same concept is used here. We have different characters, the animation, theme, and even sound effects are kind of same from that Ben 10 watch. Let's open up this app once again. So right now I'm closing all the apps in the background and opening up the Omnitrix app. So this is the loading animation. Here we have different characters that you can choose by rotating your watch bezel. Also, you have to download the phone app to fully understand the working of this Omnitrix app.